Welcome back to part 2 of tables of proportional relationships. What I want you to do is pause the recording, read this problem, solve it using good high quality supporting work like I showed you, and check your answers. Pause the recording now and do that, please. Okay, so now it's my turn to solve the problem. I've got 3 different ratios set up here. I've got, whoops, need to get my pen out. I always forget to do that. 15 is to 40, 30 is to 80, and 45 is to 120. And I need to get these to where they have a common base one way or the other, or to where they're just flat simplified. And that's my goal. I want to put them in simplest terms. So the first thing I want to do is ask, what is the biggest number I can divide 15 and 40 by? And the answer to that is going to be 5. So I do 5 over 5, which is going to give me a 3 over 8. That number is simplest terms, so it is done. 30 over 80, biggest number I can divide both the top and bottom by 10, I think here, and that's going to leave me with a 3 over 8. Once again, that is the same as the one up above it. And the final one, 45 over 120. Now that one's harder. That one I can't do on one step. Well, I could, but I'm not going to. So I'm going to start off by trying a piece that I see. And the piece that I see is 5. I know that the top and bottom is divisible by 5. 5 goes into 45 9 times. 5 goes into 120. Well, that's going to be 24 times. Now, looking at that, I realize there's another number I could divide. 9 and 24 are both divisible by 3. And if I divide 9 by 3, I get 3. If I divide 24 by 3, I get 8. And what do you see? All 3 of our answers simplified to be the same number. Since all 3 of our answers simplified to be the same number, our answer is indeed, our table is indeed going to be proportional. It checks. We are good to move on to the next resource. Resource number 7 says proportional relationships in tables. A ticket agency charges a $6 service fee on any order. Each ticket for a concert costs $25. Is the cost of an order going to be proportional to the number of tickets? How will you begin solving the problem? Make a table. From here, that's exactly what we want you to do. We want you to take the table here, look at it, fill it in, figure out how much 1, 2, 3, and 4 tickets are going to cost, and then check your answers and go from there. Going back to show the problem, whoops, that's not what I meant to do. Going back and showing the problem here, remember it's a $6 service fee for each order, and each ticket cost a total of $25. So with that, we can take that our first one is 25 plus $6, that's going to be $31. But as we go on through that, 2 times 25 is 50, plus 6 is going to be 56. 3 times 25 is 75, plus 6 is 81. 4 times 25 plus is going to be 100, plus 6 is going to be 106. The cost of each additional ticket is an additional $25 because the service fee is only charged one time. Doesn't matter how many tickets you buy, you only have to pay that $6 service fee one time. To compare the ratios of these relationships to the total cost of the number of tickets as a ratio, written with a denominator of 1. In other words, they want you to take and divide these into unit ratios. So the first 2 they did, 31 over 1, well, that already had a denominator of 1. 56 over 2, they divided by 2 over 2 to get to 28 over 1. You pause the recording and you do the next 2 and check your answers. Alright, if my mental math is good, this one here is going to become, oh, wait a minute, maybe not. Gave us a tool to use, so I'm going to say 3 goes into 8 2 times, which is going to leave me with 6, 2 left over, 21. Yeah, this is going to be the answer I was thinking. It's going to be 27. So let's take and select that. put it in there. And then 106 divided by 4, well, that's going to be a little bit different. That one, if we create it as a fraction, is going to be 25, 26, and 1/2. So let's try 26. I'm thinking I'm going to put that in as 2650 because we are dealing with money here. Oh, I see. Well, I know why we got to do it, because we're doing it as a fraction. I totally missed that we're doing these as ratios. So let me take and change these. So that's going to become 26.5 to 1 for that one. And let's see if I can get in here and get rid of these. There you go. I'm going to hit accept. And then this one right here, I need to go back and I need to change it to be 27/1 because they do have these listed as a ratio. Hit accept, and now I'm going to check my answer, and boom, those are good. For the next part, because the ratios between the quantities are not the same, the cost of an order is not proportional. Check your answer, ding ding, we are good again. So what part of the scenario made the situation non-proportional? It was a $6 fee. By adding that $6 fee before you stuck in all the other information, that's what made it non-proportional. Moving on to resource number 8. The Vista Marina rents boats for $25 an hour. In addition to the rental fee, there's a $12 charge for fuel. The table shows the amount paid for 1, 2, and 3 hours. You pause the recording, answer the question, check your answer, see if you're right. Make sure you're using big kid math to justify your answers. Now this time I'm going to use a unit ratio, excuse me, just like our textbook used last time. So that means I'm going to set it up a little different. I'm going to flip the order the problem's given here. So I'm going to take, change my pen, $37 over 1 hour, $62 over 2 hours, and $87 over 3 hours. And with that, I'm going to take and divide by the numbers needed to make it a unit rate. Now this one, it's already a unit rate. I don't have to do anything to it. It's already compared to 1 hour. This one here, I'm going to divide by 2 over 2. 62 divided by 2 is going to give me $31 over 2 hours divided by 2 is 1 hour. And then this one here, I'm going to divide by 3 over 3. 87 divided by 3, well, let me do a little bit of math on that. Hold on, that's going to become 2 with 20, it's going to be 29, if my math is right in my head, and 3 divided by 3 is 1, so that is $29 for 1 hour. You can see that each one of these numbers is different, and because each one of these numbers is different, is our answer going to be proportional or non-proportional? The correct answer is, of course, going to be non-proportional. Check it, and there we go. Now we're bringing in a brand new vocabulary term, constant of proportionality. Two quantities are proportional if the ratios comparing them are equivalent or constant. That constant ratio is called the constant of proportionality. The constant of proportionality is the same value as the unit rate. Suppose that the creators of the stop motion animation field created 24 frames per second. The table shows the number of frames captured over 1, 2, 3, and 4 seconds. What is going to be the constant of proportionality? Well, if we were to take and divide each one of these by the number of seconds, you'd get 24. 24 is the constant change between each step in the number of frames, making 24 the constant of proportionality. And what is the unit rate going to be? 24 frames per second. And what does per second mean? It means per 1 second. Therefore, you have 24 over 1, making the constant of proportionality 24, and the unit rate 124 frames per second. Two different answers you need to be able to identify here. What did you notice about the constant of proportionality and the unit rate? Well, they both had 24 in them, didn't they? The numerator in the unit rate is going to be the same as the number in your constant of proportionality. Now let's learn to identify the constant of proportionality. The winner of a jump rope competition jumped 124 times in 20 seconds and 186 times in 30 seconds. What is the constant of proportionality? Well, they're telling us right there that it is going to be an equivalent ratio, that it is proportional. They've already told us it's proportional because it has a constant of proportionality. And remember, how's the constant of proportionality and the unit rate related? The unit rate compares that constant of proportionality to 1. So let's move forward. Now they want us to drag the ratios around to make equivalent ratios. Two different proportions. They want us to take and compare the number of jumps to the number of seconds. We can see that because they have jumps over something and something over seconds here. So, going back and looking at our problem, it says that the winner of the jump rope competition jumped 124 times in 20 seconds. That means that 20 seconds is going to go right here. And it also says 186 times in 30 seconds. So the 186 is going to go here. Both of those numbers simplify to be 6.2 jumps in 1 second. With that, we ended up getting the correct answer. Now, because of that, because the constant ratio is 6.2 to 1, the constant of proportionality is 6.2, the unit rate is 6.2 jumps per second. Check our answer. Boom. Excellent. Let's keep moving. If the relationship was not proportional, would there be a constant of proportionality? Think about it. Not proportional, proportionality, no. You have to have a proportional relationship for there to be proportionality between them. Now it's going to be your turn to solve a problem. Pause the recording, read what it says, answer the question, and check your answer. I'll come back and show you what I got. Now this problem is going to involve some pretty unfriendly math. So I'm going to use Satan on this one. I don't want us to eat up all of our time doing long division. So I'm going to start off by taking and grabbing a pen here and say the very first ratio was $163 to 420 wristbands. And we need to find out which one of these is equivalent to that one. So I'm going to set up some more ratios. I can do 31:20 for 80. I can do 150.80 for 520. I can do 126 for 315, and finally I can do $84 for 240. And we're going to use that calculator and grind out each one of those numbers. So the first one, 163.8 divided by 420 equals 39 cents. So my constant of proportionality is going to be 39 cents, or 39 cents per ticket for a unit rate. My next one, I've got 31.2. Oh, clear it out, missed something. 31.2 divided by 80, and that's going to give me 39 cents again. So we know that those two are equivalent. Next one, I have 150.8 divided by 520, and what do I get? I get something that is not equivalent, 29. So we know that B is not a good answer. We know that A is a good answer. 126 divided by 315, and when we do that, we get 0.40 which means that C is also not a good answer. And our final one, we're going to take 84 and divide that by 240 and get 0.35. Once again, not a good answer. So with that, we can go back here, select A for our answer, check our answer, and ding, we are correct. That will be it for part 2 of chapter 1, lesson 3. When we come back, we get to play with a volcano. It has a clock on it. This might just be pretty cool. Come back and join us for part 3.